Hi, hello everybody. So in this video, we're going to cover section one, which is linear and absolute value equations. Now, I've divided the video into two parts. This is the first part where we go over the linear equations, and we're going to go over the absolute value equations in the second part of section one. Okay, so I have a concept here what a linear equation is. It may be obvious to some of you, but a linear equation is just an equation that forms a straight line when you graph it on the coordinate plane. So if we have an equation of this form, this is what you probably have seen it before, where there's a number multiplying the variable x and plus or minus another number. This is what we call a line. It may be many different positions, but it's a line. The reason we called a linear equation is because the exponent to the variable x, right, is 1. So normally when the exponent on a variable is 1, we don't write it, so we just write mx plus b. For example, 2x plus 5 minus 5x minus 3, and so on and so forth. So these are just functions in the way I wrote it here. Now, an equation is when we have, something as you see over here, or in problem 1.6, when the variable that we're trying to solve for has an exponent of 1. So take a look at all of these x's here in 1.6 and the q's in 1.4. If you don't see an exponent, then that means the value is 1, which means that the equation is linear. Now, the goal in solving a linear equation is going to be isolate the variable that you're trying to solve for in one side. And through the process of addition, subtraction, multiplication, and division on the equation, we're going to isolate the variable in one side and the number, a number, on the other side. Now, if you have parentheses in the equation, they must be removed first. And usually if you have fractions, it's also best to remove them before the actual solving takes place. Now, it's also important to notice the following thing. A linear equation, as you can see in 1.4 and 1.6, is an equation where you have just a single variable. Okay. Here we have a q, and here we have an x. So I can only have a single variable here. I can have multiple occurrences of the same variable, but only one variable. So if the problem is involving q, you can only have q. If the problem is involving a variable x, then you can only have x. Okay? The other important thing to notice is the following. The process of solving it, an equation, involves us balancing the equation with these four operations for now. Addition, subtraction, multiplication, and division. Meaning, whatever you do to one side of the equation, let's say, for example, I have 5 equals 5, which is a true statement. If I add 1 to the left side, I have to add 1 on the right. And now the equality is balanced. If I divide everything by a number, then I have to divide it on the other side. Okay? 5 plus 1, 6 over 6, 1. Same thing here. Same thing on the right side. If I multiply everything by a number on the left side, I have to multiply by a number on the other side. And that's how we keep the equation balance. So this is the technique that we're going to employ right here in solving these linear equations. It's likely that you've probably seen this before, so it's not a total surprise. But let's see how this is done right here. Okay. All right, so let's solve 1.4. Now just keep in mind that I've chosen these two problems to highlight it on the video, but in the workbook there are more that you can practice. So I'm going to use addition, subtraction, multiplication, and division to solve this equation for the variable q. And for the purposes of the video, this and all the other videos, I am always going to leave the variable on the left side, and I'm going to move the number to the right, okay, with these four operations. So when I look at this problem, just keep in mind that you can solve the problem by leaving the variable on the right and the number on the left. This is also okay. Okay. So the first thing I see is I have an occurrence of the variable on the right side here. So I am going to get rid of this 2q on the right side. And the only way to do that is by subtracting 2q from the right, because the plus 2q and the minus 2q will cancel each other out. And this is what I want. But if I do this on the right side of the equation, I must do it also on the left in order to keep the equation balanced. So now I'm going to subtract 2q from both sides. So here they cancel. And on the left side, I end up with negative 4q. The minus 7 still stays the same. And here's the positive 3. Now, the negative 7 cannot be here because to solve for a variable, I must isolate it on that particular side. So if there's a minus 7 here, in order to nullify it, I need to add 7. And if I add 7 to this side of the equation, I must add 7 to the other side. Now I perform the addition. These cancel. I am left with negative 4q and 7 plus 3. So notice that I started with this very complicated equation, and now I have a much simpler one. It's still the same equation, but now this is way closer to a solution. All I have to do is have the equation look like this: q equals a number. So in order for me to do that, I have to get rid of this negative 4 that is multiplying my q. Now notice I cannot just subtract 4, because if I subtract 4, it's not going to get rid of this negative 4, which is multiplying the variable. So if my number is multiplying my variable, I have to divide by it in order to simplify. And if I divide it on the left, I divide it on the right. So now the negative 4 here cancels with the negative 4 there. And I'm going to be left with just q on the left side. And I have this negative 10 over 4. Remember to never leave a negative as your denominator. I have this negative 10 over 4. Now I'm almost done. Notice that I have a single variable here, 1q equals a number on the right side, but this fraction can be simplified. So anytime a fraction can be simplified, you must simplify it. So we can simplify it by 2. So you divide numerator and denominator by 2. So I end up with negative 5 over 2. So the final answer for this problem is negative 5 over 2. Okay? So this is how you solve these linear equations. So in this example, we use the addition property, we use the subtraction property, and we use the division property. All right, so let's do the exact same thing with 1.6. And now In 1.6, I have a much more complicated equation, but still linear, right? I only see here x to the first power, but I see parentheses. So I'm going to first remove the parentheses in order to proceed. So when you have parentheses, the number or the variable that is in front of the parentheses must multiply every single term that is inside. So 3 times x, 3x, 3 times 8, 24, 4 times 2x, 8x, 4 times 3, 12, plus 5. Now, after the parentheses, after you distribute the number that is in front of the parenthesis or variable or number and a variable, whatever you have in front of the parentheses, you have a similar situation to what you had here in example 1.4, right? You have an equation that is linear and doesn't have parentheses. So what I could do is do the exact same thing we did before, right? Move all of the variables to the left. So I have a 3x here. This is going to stay here. And I have an 8x here, which cannot be there, right? So I have to concentrate all the variables in one place. So I'm going to subtract 8x. Now, why am I subtracting? Is because there is no sign in front of the 8x. So by default, it's positive. So I subtract 8x on the right, which means I have to subtract it on the left. Here they cancel once I add them. And here I end up with negative 5x. Now the 3 stays the same and the 24 stayed the same. And I have 12 plus 5. We can immediately add. But I'm going to write 12 plus 5. If you wanted to, you could immediately add them right now. Okay. And I'm going to do the exact same thing here with the 3 and 24. I'm going to combine these two and I get 27. So I'm left with negative 5x plus 27, and I'm going to add those two. And now it's pretty much similar to what I had over here, right, in 1.4. It is the same equation as the one we started, but it's much simpler because we've combined and rearranged terms. Now, to solve this equation, I have to isolate the variable in one side, so the 27 cannot be on the left. So I'm going to subtract 27, and if you do it here, you do it on the other side as well. Add them. The minus and plus 27 cancel, and I get positive 17 minus 27, which is negative 10. Okay. Oh, yes, I also forgot. Here at the very end, we also use the, yes, I mentioned that, the division, right? We just did not use multiplication. But in this one, in 1.6, notice that we kind of are multiplying them in a way. All right. So at the same, exactly the same way as we did before at the very last step, I have to get rid of the negative 5, and we can only do that by dividing both sides by negative 5. Now, don't confuse with subtracting 5 from both sides. If you subtract 5 from both sides, you don't get rid of the negative 5 multiplying the variable. And when we divide it, then those two coefficients cancel. I'm left with x. The minus divided by a minus becomes a plus, and 10 divided by 5 becomes a 2. Okay, so this is the answer for 1.6. Now, I'm not going to check it here for you, but you could do it. How do you know if x equals 2 is actually a solution? How would you know that? Well, this is what you would do. You would replace x with 2. Maybe we can do it real quick. And confirm that the left side is equal to the right side. Let's check. So I have 3 plus 3. Now, 2 plus 8 is 10. I'm going to write it here. So obviously this side I'm going to have 33. And let's see what's on the right side. 4. 2 times 2 is 4, plus 3, 7. Inside of the parentheses, plus 5. Okay, so this 28 plus 5, 33. So that checks. So this is something that you can do to check your work to see if it's correct. All right, so this is the first section, part 1, linear equations.